Hello students. So we learned in the Newton's first law of motion that when there is no external force acting on an object, the body or the object will continue in that particular state itself. If it is moving at a uniform rate, it will continue to move in that particular uniform rate itself. Else, if it is at rest, it will continue to be at rest. So what is needed to make the object change its state? Bingo, that is the state of motion. So when the object needs to change a state of motion or state of rest, that is, a force is needed. That force needs to be an external force. We'll learn more on this in this particular topic, that is the Newton's second law of motion. We have already discussed about the Newton's first law. So let Professor Mack explain it to us, the Newton's second law of motion. So like we understood about the first law, in the first law, that you need to have external forces for the body to change a state. If it was at rest, it will not move on its own. You need to have an external force to be acted upon the object. So for Newton's second law of motion to be understood, again we'll need the force, and that needs to be acted upon an object, right? So you cannot have any object moving on its own unless you apply an external force. That is, again, the bare minimum things are the forces and the objects. Obviously, the forces and objects together are going to define for you as to what exactly is the Newton's second law of motion. So let's try to elaborate. Let Professor Mack explain it to us using an animation as to how it works. So for that, force equals to mass into acceleration. So this tells us about the Newton's second law. What does this tell us is that when you apply an external force on any mass, an acceleration is going to be produced. So an acceleration that is produced obviously is going to be a vector quantity, like force is a vector quantity. So force, F is what is force, M is the mass, A is the acceleration that is produced. So acceleration is a derived quantity that comes from the force acting on this particular mass. So this is what is the Newton's second law of motion. Unless you have any of these things missing, you cannot have the acceleration that is being produced. You need to have a mass on which the force needs to be applied. Therefore, that is only going to produce an acceleration. So acceleration cannot have any scalar analog because force does not have any scalar analog. Force being a direction full quantity or being a vector quantity, acceleration also has to be a vector quantity, right? Also, for a given amount of force, the mass is inversely proportional to acceleration, and using this we can simply also understand that force can be written as rate of change of momentum. We'll discuss more on it when we discuss about momentum and impulse later on. So as of now, just try to understand that force is equals to mass into acceleration. Acceleration is nothing but the change in velocity with time. Now let's try to do an experiment, a similar kind of an experiment like we did in the previous case. In this case, again, we have a box that is being taken in to a further distance. This is our box that we have, and this is the piston that is attached to this machine. This box has force, has the forces acting are the weight and its normal reaction. Here, this is the piston that we have. We are not applied any force on this. Now, what we need to do is that we need to bring this piston close to this box. So as of now, there is no contact between the box and the piston. This force that we are representing is a kind of a contact force. This is going to act only when the piston actually touches the box. You can see that there is a spring here. So when you are pulling the spring, obviously the spring gets extended. The spring does not want to get extended, but in this case it is getting extended by an amount equals to 5 units, right? Here, if I say that this is the box, and if I apply any force on this particular box, only then this is going to start accelerating. So obviously the piston is going to produce a force, or I can apply the force from the box onto the piston. Either way it is going to work. So either I can compress this spring or I can elongate the spring. Either way the force is going to be there, but obviously there is going to be different in direction. As I mentioned, there is a gravitational force or the weight that is acting in the downward direction, and a normal force that is on this surface. This box has been kept and this does not fall down. That implies that there is a normal force that is acting on this. So let's try to understand more about it. What can be the other forces that are acting? So let's see. We have the force. The horizontal force is going to be given by mass into acceleration. So since this depends on the velocity, obviously the change in velocity is what we define as the acceleration. Mass is here, so the force produced along the change in direction of velocity, that is what we define as the acceleration. Going further, we can say that the force divided by the mass is going to be equal to the acceleration that is produced. Therefore, force can also be written as, if the force is equal to 0 Newton, that means if the applied force is 0 Newton for a given amount of mass, whatever can be the mass, in that case the acceleration that is going to be produced is going to be 0, because from this particular relation acceleration will come out to be 0 units, or it's going to be 0 meter per second square. So this tells us that there should not be any acceleration if I do not apply any force on the object. That is, the object should be moving at a uniform rate. That can happen if I only apply the force for a particular instant of time and then leave it, and the object is going to move at a uniform rate. Let's try to do it. Let's try to understand how that experiment can be performed. So again, this is the box, this is the point at which this piston is going to end up, or we have to bring this point in contact with this piston. So let's say this has been brought in contact with this particular piston, and this piston has got slightly compressed. Let's see whether it has or not, or whether it is at its normal position. Yeah, it is still at its normal position, because okay, it has been compressed. So it has been compressed by 5 units, because initially we saw that it is at this particular point. So it has been compressed. So when it has been compressed, obviously there is a force that is acting on the object. As a result, this we can simply write it that it is covering different distances at different intervals of time. At 0 second it was here, 1 second it is here, 2 second it is here, 3 second it is here, 4 second it is here. So you can see that for the same time interval, the distance that is being covered is different. So if the distance that is being covered is different, that means the velocity is changing at every instant of time. So if the velocity is changing at every instant of time, what does that mean? It means that there is an acceleration that is being produced. So an acceleration is going to be produced when there is an applied force acting on an object. So here, if we try to see it, when this block was pressed, obviously the spring got compressed. As a result, because of this compression, there was a force that started acting on it. So this was its original position, and this was the amount by which it was compressed. So using that compressing force, the object moved in a forward direction. So that is what is the Newton's second law. So let's try to elaborate further on it. So the Newton's second law basically deals with the momentum of the body. So when the object starts moving, whenever it is having any particular velocity, it will continue to move with that particular velocity till you apply an external force. But as soon as you apply an external force, the change in state of the body or change in motion of the body is going to be there. So that is what is meant by the Newton's second law of motion. So taking it further, if we have to define it, we need to define it in terms of momentum, like I mentioned. So the momentum, what exactly it is? The momentum is nothing but the product of mass and velocity of a body. So the product of mass and velocity at any particular point, that is what is defined as the momentum at that particular point. So mathematically speaking, momentum P is equals to mass into velocity. Therefore, for the Newton's second law of motion, we can say that the rate of change of momentum of a body is equal to the force that is applied on the body along the direction of the application of force. So that is what is defined as the Newton's second law. Mathematically speaking, we can say that F is equal to dP by dt. So what is dP? dP represents the change in momentum, dt represents the change in time taken. that is equals to mass into acceleration. If we want to find out a differential form, so a differential form is going to be given by the change of momentum with time. So change in momentum can be written as mass into velocity. So d of mv by dt. For a constant mass, obviously the mass will not change. I can take out this mass factor out. So this becomes dv by dt. dv by dt is nothing but the change in velocity divided by the time taken. So that is how we define the force. We know that the force, velocity, momentum, these are all vector quantities, and therefore all of them have magnitude and a direction associated with it. So on that note, I end it. I see you again in the next topic, that is the concept of momentum, which is going to be further elaborated. Thank you. So students, we learned about the Newton's second law of motion. What basically was needed for any object to change its state of rest or motion is force. So we learned about what exactly is the force that is needed, what are the types of forces that are needed. Further, we also understood about the free body diagram. So what is a free body diagram? Free body diagram tells us about if any object is there, what all can be the forces that will be represented. Are the forces balanced or are the forces unbalanced? Yeah. So we'll take this further and try to understand in terms of the momentum. So the force is also represented as a change or the rate of change of momentum. So the next topic that we are going to learn about more about momentum.